All right. Hello, everybody. Welcome. Let's go ahead and get class started for the day. I'm going to spend the first 5 or 10 minutes just kind of going over the logistics for the exam, make sure everybody knows where to go, when to be there, stuff like that. And then the last hour or however much time we have left is just going to be open session for you to ask whatever questions you have about the stuff that's coming up for Thursday's exam. So let's jump right in. The exam is Thursday evening from 6:30 to 8:30 p.m. So you only need to bring your ID card, some stuff to write with, so pencils I think are a good thing to bring. And you can also bring a cheat sheet or a sheet of paper with notes on it. So this is just one regular size sheet of paper. You can put notes on it front and back. I don't care if it's handwritten. I don't care if it's typed. I don't care if you use a typewriter. Whatever you want, right? You can put whatever you want on there. I'm actually not super strict about this sheet of paper. I use common sense when thinking about this. So if you're wondering about the rules, restrictions, it's just a regular size sheet of paper. Not going to be walking around with a ruler measuring, to the ½ inch or anything like that. If it came out of a notebook or piece of printer paper, that's fine. If you walk in with a sheet of paper as big as the desk, then all right, we're going to have some problems. But, otherwise I'm probably going to let it slide. As far as the content, front and back, right, handwritten or typed, I don't care what you put on there. My only rule with the content is that if I'm walking through the exam room and I pick up your sheet of paper, I should be able to look at it and tell what's on there without having to do anything strange, right? So if I need to put on 3D glasses to see what's on your cheat sheet, then that's no good. I don't want to see stuff like that. But yeah, so just common sense. Keep it simple. It's not meant to be a big deal. You'll notice that no calculators, no electronics of any kind. So this is a mathy kind of class, I understand. There may be some math on, there will be some math on the exam, that's for sure. But it's going to be simple arithmetic kind of stuff. Any kind of math that you have to do will be simple enough that you can either do it in your head or maybe just real quick in the margins. It should not require a calculator, not even a 4 function. You will not be allowed any kind of electronic devices during the exam. So actually, when you come into the exam room, typically what happens is the TAs will ask you to drop your backpacks with your up in front of the room and leave your cell phone in there so that just all electronic devices are put away and aren't going to be a distraction during the exam. And then once the exam gets underway, just want to make sure you're all aware that you can ask for help during the exam. However, the TAs have been given very strict instructions not to answer any questions about the exam during the exam. The reason being that there are hundreds of people taking this exam in many different places. So if one TA answers a question in one room, there's no guarantee that information gets to the other rooms and it creates an unfair situation. So the TAs have been very clearly asked not to answer any questions about the exam. You can ask, but be prepared to be said, sorry, I can't help you. Which means that if you get stuck or you're confused or something on the exam doesn't look right, you just got to do the best you can, right? Do the best you can. The TAs are not going to be able to help you, unfortunately. That is for the sake of fairness. If there really is an issue with the exam, like a typo or something like that, if it's brought to my attention, then I will announce that to all of the rooms, have the TAs announce that, but otherwise you will not be able to get assistance. So it's not that your TA is being a jerk to you, that's just how we run exams. And then the other thing that you should be aware of is where you need to go. So that's based on your ID number. There's a lot of people taking this exam, so we've got 3 different rooms reserved: Louderman, McDonald, and Simon. So take a look at the last 3 digits of your ID number and make sure you know where you're going. I would highly recommend to figure this out before Thursday. Especially want to point out McDonald 162 as being a room that students traditionally have a hard time finding. There aren't a lot of classes in that room, so it's not a room that people are going to very often. Can be a tricky one to find, so especially if you're in McDonald 162, I would recommend you go there before Thursday. Make sure you know where it is, make sure you know how to get there. We are starting at 6:30 sharp, so if you roll in at 6:45 and say, I couldn't find the room, sorry, I Please make sure you know where to go ahead of time. Simon 1 and Louderman are very common rooms, so most people generally know where those are, but never hurts to double check and make sure you know where you're going. The TAs will be checking IDs, so it is possible that if you show up to the wrong room, they'll ship you out to the correct one. So please try to check that, get that all squared away. And then last, I just want to make sure for anybody that has accommodations, typically that is either extended time on exams or distraction, reduced test environments. I hope that you've already talked to DR about that. You will have to take the exam through DR if you wish to use those accommodations. So if you haven't spoken with DR about that, please do so as soon as possible. With these exams being in the evening, we just do not have the capacity to have people stay past the exam time. So if you show up to these exam rooms, you will be asked to leave at 8:30. If you have extended time accommodations, you cannot take the exam in the exam room and use those accommodations. You'll have to do it through DR. So talk to DR as soon as possible if you need to. If you need to loop me in on any emails with them, I'm happy to do whatever I need to make sure that you are set up to take the exam properly. I think that's about it in terms of the logistics. Does anybody have any questions about the who, what, where, when before we talk about coding stuff? Any questions about where to go, what to bring, cheat sheet stuff? Okay. One other kind of scheduling note that I want to bring to your attention regarding class later this week. So typically we would have a studio on Wednesday or Thursday, but we don't this week. There's no studio this week. There is still an assignment due. However, assignment 3 is due this week. So you can still come to class on Wednesday or Thursday to turn that in if you need to. You can also turn that in during office hours if you would like to. The TAs will be there if you want to come in to class on Wednesday or Thursday, get exam help. So the TAs will be there. They can go through exam problems with you if that's what you'd like to do. If you have turned your assignment in and you don't want to go in and ask exam questions to the TAs, do something else. I don't care. You're adults. You can decide how to spend your time. There's no studio. So if you feel like your time would be better spent doing something else on Wednesday or Thursday, then great. Do that. That's fine with me. I don't have a problem with that at all. But we are available to help you if you would like to do that. All right. Last chance to get in non-coding, non-computer science questions before we jump into computer science stuff. Any scheduling or other questions? Okay, then we'll go ahead and switch over and talk about the content next. It's the first exam, so the stuff that's going to be on there is pretty easy to talk about. It's everything we've done so far. So we've got, the very first week we talked about variables, right? And then we switched to if statements and loops in the second week. And then this past week we just talked about arrays. So those are kind of the major things, the major topics that you can expect to see covered on this exam. There are some smaller little bits and pieces here and there that we've discussed as well. I have published some information to help you study, so I hope that you are aware of these study materials, but just want to make sure that you are aware that I posted a whole bunch of, I posted a practice quiz on Canvas. These all feature multiple choice and fill-in-the-blank style questions from past exams. There's a bunch of them, so there's a whole bunch of stuff that you can go take a look at. And then I also posted this repository, this coding prep repository that has a whole bunch of code reading problems. So get out a piece of paper and see if you can figure out what this code is going to print out, and then you can run it and check your answer. And then some code writing problems. You can see we were working on some of those a little bit last class. So lots of stuff that you can use to help study. All of these will be on your exam in some form, right? So it'll have multiple choice, fill in the blank. It'll have some code reading questions, and then it will also have some code writing questions.
The most anxiety-inducing ones, of course, are the code writing questions. I get a lot of questions about those. So let's talk about that for a second in terms of test-taking strategies and also kind of what to expect with the code writing questions. I want to make it clear that I do try to give out partial credit on not just these questions, but any questions. So if there's a multiple question that's worth multiple points, I want to give you as much credit as possible. So be smart about that and don't leave anything blank. Especially these coding questions at the end, which are typically worth a big chunk of points. I can't give you partial credit on a blank question. Blank questions are going to get zeros. But if you put something down on the paper, I will do whatever I can to try and give you some points for it. So please try and show me something, anything, so that I can try to give you some credit. The other thing, just a more general strategy when it comes to these coding problems, and I'll, if we go through some in class, I can try to reiterate this too, but I mostly equate these to word problems from math class. I feel like you've probably done those kinds of problems for quite some time now, where you're faced with a problem and really the goal is to try and pick the correct equation or operation that needs to be applied. Or if you want to go like way back to like when you're doing it in elementary school, the simplest example would be like Bob has 3 apples and he gives 2 apples to Jim. How many apples does Bob have, right? This is just, the coding questions are just grown-up versions of those kinds of problems, quite literally. You know more than subtraction now. The tools that you have in your toolbox are variables, if statements, loops, and arrays. So when facing the coding questions on the exam, read over the problem and then try to think, all right, of those tools that I have, how can I apply those to the problem that I'm trying to solve? If there's repetition, there must be a loop in there somewhere. If there's choices to be made, decisions to be made, there must be an if statement in there somewhere. So trying to come up with those mapping of the concepts to problem solving, that's really kind of the whole purpose of this class and why we ask you to do the homeworks and all that stuff. So that's enough of me rambling. I'm going to shut up now, and for the entire remaining hour and change, I'm going to let you all direct where we go next. I'm happy to go through any of these practice problems, either from the code writing, code reading, practice quiz on Canvas, or just general conceptual stuff. Whatever would help you all, I'm here to help. So who has some questions? Yes? Those do exist, but this is a computer science class. I get asked about the format of this exam, but this is, if I ask you multiple choice questions or essay questions about computer science, I would expect you to be able to answer either one because this is a computer science class. So I'm going to go ahead and say right now, any future questions about the format of this exam are not going to be received well by me. I'm just not a fan. This is a computer science class. Not the answer you were expecting, I'm sorry, but that's how I feel about it. Somebody want to ask me some comp sci stuff?
Yes? How important is precise syntax for the word problem?
Oh, great question. Yeah, so I'm glad you asked that. I meant to say this when I was talking about this before, and I forgot. There are some kinds of errors that I very much am not interested in testing you about. So the very simple kinds of errors like, oh, I accidentally a semicolon, like these kinds of things happen all the time. But, nobody in this class is, I'm sure everybody in this class is aware that you need semicolons, and even if you do make that mistake, right, Eclipse underlines it in red and says, hey, you need a semicolon here, right? I'm not going to mark off for stuff like that. If you forget a semicolon, you're not going to lose points for that. Little kinds of mistakes like that. The general rule is if Eclipse would underline it in red, I'm probably not going to mark points off for it because I know you're smart enough to look at it and be like, oh yeah, Eclipse tells me I need to fix this. So, you don't need to worry about that. That doesn't mean that you can just start throwing a bunch of slop on the paper and I'm not going to worry about it. I do hope you at least try to write clean, effective code on your paper, but you don't need to freak out about it being exactly perfect. That's kind of the point I'm trying to make. Yeah, hope that helps answer your question. Any other questions that I can address? Yes?
When it comes to concatenating a string with a number in it with just a regular integer, would that always become a string no matter where the string is concatenated?
Yeah, the question was about concatenating ints with strings. Would it always become a string? Yes, in fact, I would take that one step farther and say when concatenating a string to anything, the result is string. Whether that be an int, a double, another string, although that's probably obvious. But yeah, the result of a concatenation with a string is going to be a string. And actually, though I'm not sure if this was mentioned specifically in the textbook, we do have a name for this. It's called type widening. If you think about it, the amount of values that you can represent with a string is much larger than the amount of values that you can represent with an int, right? Because strings can contain things like letters and punctuations, and ints just can't. So in computer science, we would say that the string type is wider than the integer type because it can represent more possible values. And whenever you're tasked with thinking about which type a certain thing is going to be in, we always pick the widest one, the widest type. So strings are a very wide type, very, very, very wide type, capable of representing many, 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 many different possible values. Ints and doubles, booleans, much more restrictive, much narrower types. Do I see a hand right behind you there?
Yeah.
Yeah.
So adding on to that question, so if you have like a string and then you're adding that to a boolean, would that also be a string?
Yes. Yep. Yep. I'm trying to think of an example of concatenating anything with a string that wouldn't be a string, and I'm having a hard time coming up with one. I don't want to say that there isn't an example, but I think at least for the purposes of this class, it's pretty safe to say that if you're concatenating a string on it, it's going to be a string. Somebody might be able to find a counter example, but yeah.
So for question 18 on the past exam coder reading, I was confused why the output gets rounded. I know it's a double, but I don't understand why it gets rounded.
Why the output gets rounded.
Yeah, so for example, like when you print the output, it's like 2.6 is actually 2.55, but it's rounded to 2.6.
Well, let's walk through it. So, and see, it's been a minute since I thought about this problem. I'm going to step it through the debugger because I think this is kind of a good way to walk through these problems and also just kind of good review. Big fan of the debugger. If you're working through these code reading problems and you're ever like, huh, why did it do that? The debugger, I would hope, would be one of the first things that you consider using to help you understand these codes. So I just put a breakpoint on line 14 here, the very first line of the code, and I'm going to start it in debug mode by clicking the little bug up here at the top and switching into debug mode. And so I'm now paused on line 14, and I want to step through this code one line at a time, which I'm going to do using these yellow arrows up here at the top. Right now, the difference between these two yellow arrows is not really important to us. It will matter a little later, but for right now, I'm just going to click step over and watch my variables on the right side as we travel through this program. So here we can see that D starts out as 5. I print out 5 plus 0.1, which is in fact 5.1. So I believe that'll be the first value that we see. There it is. There's my 5.1. And then I'm dividing D in half. So 5 divided by 2 should get me 2.5, correct? So I'm not dividing 5.1 in half. I'm dividing 5 in half. 5.1 divided in half would be 2.55. But 5 in half is 2.5. And then when I add 0.1 to that, as I print it out, that's where I get the 2.6. So it's actually not rounded. It's exact. It's doing the arithmetic as specified. This 0.1 is not part of D. I think maybe that's where. Yeah. And so then just to round this one up, I think there's just one more trip through. We divide 2.5 in half to get 1.25. And when we add the 0.1 to that, we get 1.35. And I believe, yeah, so now we divided it again. It's now less than 1, so the while loop is going to exit. Yep. Any questions about that problem? Or the debugger? Any questions about how I was using the debugger there? Great tool. I'm going to be using it many times. Would love to answer more questions about it if you haven't. I guess just as one final reminder, make sure to click that red square to stop the debugger once you're done, and click the J up here to go back to the normal view. Did you have a question, or is that? That's what you were about to ask. All right, I read your mind. Yeah. Click the red square to stop the debugger, and then click the J at the top right corner to switch back to the normal view. All right. What's next? Who has some questions, or who would like to ask a question next? Coding problems, conceptual stuff. Yeah, top.
Could you go over one of the code reading functions just to kind of give an idea of how you go about that on the test? I guess my main thought is, are those formatted in a way where we read the code and then answer like multiple choice questions, or do we write out the code in words in response?
You're writing this.
Okay.
I want to know what's getting printed.
Oh, okay.
Yeah. It says predict the output, so this is what I was looking for. So yeah, you got to check out where the print statements are and see what's getting printed. And be careful. This one has a little X in quotes, not a variable, right? Although there is no variable. That would be mean if there was a variable X and then I put that. That would be mean. I wouldn't do that to you. Well, no, I wouldn't do that to you. I haven't written the exam yet, so don't give me any ideas. Yeah.
When you do like the greater than sign or the less than sign, or the and operator or the or operator, is that always a boolean?
Okay, so the question was, if you do the greater than, less than, or the ands and the ors, is the result always a Boolean? Yes, actually. Everything that you just named are examples of Boolean operators, but there's actually, you can subdivide those even further. So ands and ors, and then also not, I would also include in that category. We have a name for those operations. Anybody remember what those are called? Starts with an L. Rhymes with logical? I don't know. It's a hard word to rhyme. Logical operators are ands, ors, and nots. And then the other category would be the greater than, less than, equal to, not equal to. What are those called? There's two words you can use to describe those. One starts with a C and one starts with an R. Greater than and less than describe how two values. It's the same word you'd use in math class. Pretty sure. I'm sorry? Compare is one of them. Yeah, comparison operators. That's one of the two words. The other one that starts with an R, relational operators. How do two numbers relate to one another? I would accept either answer. But yes, to answer your original question, both logical operators and relational operators are going to give you a Boolean as the result. That is correct. What's next? Who's got some more questions? Yes?
I know this may be a little hard to answer because you haven't written the exam yet, but do you know about how many questions the exam would have in total?
Nope. Do not. Question?
As far as order of operations goes, where do Booleans fit in?
Aye, great question. Love that question. So, yeah, we've talked about order of operations in this class, and the good news is that your PEMDAS operations, or however you learned it from algebra all those years ago, still apply. So parentheses, multiplication, all that stuff is still the case. However, we've shown you a bunch of other operations. So you didn't have ands and ors and greater than, less than in math class when you were learning about that stuff, but they're still part of the order of operations. And so there's a general answer and a more specific answer. There's a chart. You can look at this chart. This is called the precedence chart. It's basically the order of operations chart for every operation in Java. And so there's parentheses right up at the top, right where you'd expect them to be, and then you see addition, subtraction, and multiplication, division comes first, and then addition and subtraction. And then we actually don't get to the Boolean stuff. The logical operations are down here. So there's logical and, logical or, And then actually the relational operators are actually right before that. So the bigger takeaway, the more practical way of thinking about it, is that the Boolean operations, the relational stuff, and the logical stuff happens after any arithmetic. So if there's math involved, do the math first. And then if there's Boolean stuff to do after it, do that. Now parentheses, right, can change any of that. So if you got to follow the parentheses if those exist. But if you don't have parentheses guiding you, then do the math first and then do the Booleans after that, as a general rule. And you can see there's other stuff on this chart that we haven't even talked about yet. So, and we're not going to actually talk about everything that's on this chart. So, but yeah, great question. Yeah, go ahead.
Something like math.pow.
Yeah, math.pow. So how does that fit into the precedence chart? That math.pow is an example of actually what is called member access. So math.pow is what we would call a method. And we're going to talk about methods in Module 5, which is actually coming up not much longer after the first exam here. So math.pow would happen first, actually, generally. I think that is on one of the practice questions, too, now that I'm thinking about it. That's probably why you asked me. A lot of the times, even if you aren't sure which one is supposed to happen first, you can even just reason about it, right? Like, if you see a comparison operator involved, well, it's like I can't compare, addition to a number, so I must have to do the addition first, right? And then compare a number to a number. A lot of times you can just kind of reason about it that way. But if you want to write down the chart, you certainly can. What other questions do y'all have? Yes?
Is there solutions for like the code writing questions?
I'm happy to show you any of them right now if there's one in particular you'd like to see. I don't like posting solutions to them because there are more than one solution to these problems, and when I post solutions, people feel like that is the only solution and they have to do it that way, and I don't like that. I actually think it's much better for you to find your own path to the problem. But I'm happy to discuss any of them and talk about them now. If anybody has any questions. I mean, I'm not in a hurry. If y'all have other stuff you'd rather be doing, that's fine with me, but I'm here to help however I can. If nobody has any questions, we're welcome to just end class. Like I said, I'm here to help y'all however I can, so if nobody has any questions, you all think you're ready for the exam, you're welcome to take off and do whatever you want for the rest of your day. I'm here to help, so I'm not going to leave. I'm going to stay until class is over and help out people who have questions. But yeah.
The studio is going to be in the same place. I know there's no studio, but if
same rooms, yep.
For our homework.
Yeah, same rooms. Yeah. That's right. Yeah.
But there was a problem in that to write like things that were in the array, take certain values of the array and write them into a one.
I know exactly which problem you're talking about. Yeah, let's go through it. I think it's question 4. I did it last section too. It's a good problem. So let's talk about it. All right. So this problem starts out by giving you a two-dimensional. This is the one you were thinking about, right? Yeah, I just want to make sure. All right. Starts out by giving you a two-dimensional array of values called data. And I want to point out real quick before we get too far, this note here that I put in, right? I gave you an array here with numbers in it that you can use to practice. But when this was actually on the exam, right, it didn't have numbers in it. It just had this. I did not tell you what was in this array. I just said, here's a two-dimensional array that's got stuff in it. Your code should work regardless of how many things are in that array, right? And that's still true. This won't work. I can't write code like that's not a valid line of code. So I'm going to use actual numbers. But if you're doing this yourself, if you're trying to practice, what does that mean? That means that if you write code and you think you got it to work, well, add another row on to this array and run it again, and your code should still work. And then add 3 more rows and run it again, and it should still work. And then add some more columns too, and take some away, right? Try different sizes of arrays and make sure that the code that you wrote still works. That's important. It's very important. Code that just works for one array is not very useful to me or anybody. I want my code to work for the general case, for any two-dimensional array that I might want to work with. That's a much more useful solution for me. So just want to make sure that's clear. All right, we've got our two-dimensional array. I want to pick values from this array at random and store them in this one-dimensional array. So I'm going to ask the user to type in a value for n, which is how many random points they want. So if I type in, I want 10 random points, then I'm going to pick 10 values from here at random and put them in this array. So you'll notice that for the purposes of this problem, it's possible that I randomly pick the same number more than once. In fact, if I'm picking 10 values, I would have to. There's only 6 here, so I'd have to pick 10 values. I'd have to pick some values more than once. So what we're doing is actually, for any of you who have done statistics or any kind of data science stuff, we're doing a uniform random sample with replacement. If I was doing it without replacement, then I would only be allowed to pick each number exactly one time. That's doable, but a harder problem to solve. So we're going to stick with a simple example. Anybody have any questions just for starters on the problem that we're trying to solve? Because I think that's very important. Before you write any code, make sure you understand what is being asked of you. Yes?
This is kind of a tangent, but in what kind of situation would it be more beneficial to use a two-dimensional array than a one-dimensional array? Because you could hold those 6 values in a one-dimensional array as well.
Sure, yeah, you certainly could hold these values in a one-dimensional array. But I haven't told you what this data is for or what it represents, right? So what if this data represents, you know, the number of plants I have growing in each plot of my garden? Then a two-dimensional array makes the best sense because my garden is a two-dimensional grid and I want these numbers to represent particular positions on that grid, right? So the structure that I have chosen is whatever makes the best sense for the data that I'm trying to represent. This is just a general ambiguous data problem, so you just have to take my word for it. Yeah. But any kind of problem that takes place over two-dimensional space is going to be a great fit for a two-dimensional array. Anything that involves a grid, great fit for a two-dimensional array. Yeah. And there are lots of problems like that. Great question, though. I'm glad that you're thinking about stuff like that. All right. So we're going to pick points from this at random and put them in here. My first question is, so I have some repetition to do here, right? I'm picking random points. I'm picking a certain number of random points. Repetition means loops. So if I'm doing something n times, your brain should think, oh, I need a loop. I got to have a loop to do something over and over again, certain numbers of times. I don't care if you use a for loop or a while loop here. I think either one would actually work, but I think it's very important to understand how many repetitions we have to do here. How many times do I want to repeat? N times. The big mistake that people tend to make on this problem, which is actually very understandable, they see this two-dimensional array and they think, oh, wait a second, Professor Shook told us something about two-dimensional arrays. He said two-dimensional arrays are a great time for us to use nested for loops, right? And that's not wrong. I did talk about using nested for loops for two-dimensional arrays. I talked about using nested for loops for two-dimensional arrays when I wish to visit each position in that two-dimensional array exactly one time and do something with it, right? Is that what we're doing here? No. We are visiting our two-dimensional array at random. We're not visiting each point. It's entirely possible that we will not visit every point in the array. That is a very likely outcome for us. So the nested for loop structure while very common, very useful, is not the right tool for us here. The right tool for us here is a loop that's going to repeat n times. So there's a number of different ways that you can write such a loop, but here is one of the simplest, more straightforward ways that I can think of to write a loop that would run n times. And I now need to pick random values out of my two-dimensional array. What information do I need to pick a single value out of this 2D array? Yeah. Close, yeah. The length, which represents... So if I want to get this 2, right? What information do I need to access this 2? The row and the column. The row and the column. So if I want to pick a number at random from this array, I need to randomly select a row and randomly select a column. Correct? Randomly select a row and randomly select a column. And I need to make sure that when I randomly select a row, that it is a valid row. It's an actual row that exists in this array. Otherwise, I'm going to get an error. So let's talk about that. I need to pick a row. I know it's an integer, right? There is no row 1.5. So, okay, it's going to be a random row. So we know math.random is coming into it. Oops, there goes my phone. The smallest row number that I could get is what? 0. That's okay. The largest row number that I could get is, it's going to be based on n, right? Or not n, I'm sorry. That's not right at all. Why did I say that? It's going to be based on the array. So last class when I asked this question, somebody said the largest row that I could get is 1, which is true for this array, but I want to keep this general. So if I want to know how many rows I have in general, how do I say that? Data.length. So this tells me the number of rows, and you'll notice that I'm multiplying. We talked about how to generate random numbers within a range. The range here is from 0 to data.length minus 1. Right? Those are the numbers that I want to generate as integers. So let's work through this in our head. Math.random gives me a number between 0 and 0.999999, right? Up to, but not including 1. If I multiply this by the number of rows, so if I use 2 here for the number of rows, there are 2 rows, then I'm going to get a value between 0 and 1.999999, repeating. I don't need those decimal values though, right? So how do what's it called when I turn something from a double into something else? What's that called? I'm sorry? Not rounding. Casting? I don't think rounding would work here because rounding could take me up as well as down, and that's not actually what I want. If I rounded 1.9999 up to 2, there is no row 2. That does not exist. By casting, I am not rounding, I am truncating, I'm chopping off the decimal. So if I get 1.9999 as the result of this multiplication, I chop the 0.9999 off and I get 1, which is a valid row. This line, I am making the assertion, will generate a random row between the range of 0 and data.length minus 1. Regardless of how many rows are in this array, this will give me a valid row number. Do you see that? Does anybody have any questions about that? It's an important part of this problem. Yes? So it's because math.random is not inclusive on the upper bound. I don't need to worry about that. The largest value this could give me is 0.9999. If I have 2 rows, then that multiplication gets me 1.9999. And then this chops off the decimal. So it always goes down to 1. So if this is 10, if I have 10 rows, right? If I have 10 rows here, the largest value I'm going to get after the multiplication is 9.999999. But then I'm going to chop off the decimal, which gives me a 9, and that is in fact the index of the last row. So that does the rows. We're actually going to do a similar approach for the columns as well, right? In fact, it's going to look very, very, very similar with a slight tweak over here. Whoops, I'm sorry. Wrong place. There we go. So what is this saying? This is saying take the length of the first row. That should tell me the number of columns. So this is going to generate a random value between 0 and the number of columns minus 1. And we're actually almost done with this problem, as a matter of fact. I have my randomly selected row and my randomly selected column. I want to plug those into the array and grab a value. So data at row column, here's the value that I'm randomly selecting. I wish to put that into my points array, and I actually made this loop. You see, I made this points array after the loop. This should have happened before the loop, so that's my mistake. But if I move that line back up there where it belongs, I can now take that and put it into the points array at position I. Remember, this loop is going to iterate n times, which is how big this points array is. So I'll be visiting each position of the points array exactly one time, randomly selecting values from here. This problem's done. This problem is finished. Yes?
Why did you not do a nested for loop to this and we have like one line for both of them?
So the question was, why did I not do a nested for loop for this? So I did talk about nested for loops with two-dimensional arrays. Nested for loops are used with two-dimensional arrays because I have one loop per dimension. So I have one loop to iterate through the rows, and I have one loop to iterate through the columns. This is useful if I wish to hit every single position in a two-dimensional array. Are we hitting every position in this two-dimensional array here? Is that what the problem asks us to do? It asks us to pick random values. It does not ask us to visit each position in the array. It asks us to pick n values at random. I could ask you to choose 2 values from this array, and there are 100 values in the array, so I'm only going to see 2 out of those 100 positions. So writing a nested for loop that visits all of the positions then would be very much unnecessary. Do you see that?
Follow-up question. So for assignment 3, there's that third, like the symmetrical image.
Correct, yeah.
Would you say you wouldn't use a nested for loop for that either? Because you're randomly selecting whether it's blank or a star?
The question was about assignment 3, whether you need a nested for loop for that one for a symmetrical image. I'm not sure that you do. I mean, there are oftentimes more than one way to solve this problem, so I don't want to say that it's impossible to do it with the. I mean, you might be able to do it with a nested for loop, but I don't think you need one. Nope. I don't think you do. You know, you do still have to use a little bit of thought to make sure that the tool you're applying is the right one for the job, yeah. Just because the nested for loops work really well with 2D arrays doesn't mean that that's always going to be the case. Sometimes I like to put banana on my peanut butter and jelly sandwiches, and sometimes I don't. I don't know, that's a dumb example. But who's got a better question for me that I can go on to look at next? Who has another question for me? Yes?
Could we replace this for loop with a for each loop?
Could you replace this for loop with a for each loop?
Yeah. Like for int I, colon, whatever the name of the points, and then place.
So I think the issue with doing it that way, I'm glad that you got the syntax down for how to iterate through by value like this. But you have to be careful here. I is being used in this line as an index, as a position. When I write a loop like this, I is not a position, I is a value. So the way I had the loop written before, I is going to go 0, 1, 2, 3, 4, 5, 6. The way that I have it written now, it's going to go 1, 2, 3, the values of the array, which is not what I want. right? It's very important. I need the position here. So if I am using the loop variable as an index, then you have to write the loop this way. If I don't need an index to access the array, then you can write it as a for each loop, iterating by. I mean, it's a difference between iterating by index, which is what we're doing here, versus iterating by value, which is what you were asking about. If you iterate by value, you don't have access to the index. So if you need the index to solve the problem, then you're in trouble. Whereas if you iterate by index, you can access the value simply by plugging it into the array. So in that sense, it's somewhat safer to just iterate by index. People think it's more convenient to iterate by value, though. It's usually seen as cleaner and more concise. But not always. Great questions. What other questions are there? We've got about half hour left. If anybody's got any more questions, be happy to go through some. Yes?
For PV arrays, will we always assume they're not jagged?
Yes. In this class, we're assuming rectangular arrays, always. Yep. I don't think I even talked about jagged arrays other than to mention that they exist. What other questions can I answer for you all? Yes?
This is like an assignment 3, but can you kind of talk about how to like store values in an array that someone like gave you? Like it says like user to enter that many integer values which get stored into the array.
So I mean, I think the question really, I understand what you're asking, but I would like to reiterate this idea that types matter a lot. So if I'm making an array of integers, then any integer that I have from anywhere can be put into that array. So if I ask the user to type in an integer, for example, and I have that integer in a variable, then I can put that integer into an array if I want to. I don't know if that, I mean, I could show you how to code it up, of course, but I would like for you to do that on the assignment. That's kind of the point. But the bigger point I'm trying to make here is that, you know, if this is an array of integers, I can say x here, where x is any integer variable that I've gotten from anywhere. Scanner, I made it myself. My next door neighbor came over and gave it to me. It doesn't matter. As long as it's an integer, I can stick it in that array. So hopefully that kind of helps move you in the right direction. One other tip that might help, you can do scanner stuff inside of a loop if you need to. Why not? If I need to ask for a lot of values, if I need to ask the user to type in many values, then I'm probably going to need to do it inside of a loop. Yeah, what other questions do y'all have? Anything else you'd like to discuss? Yes?
So for question 8 on the writing,
Uh-huh.
the writing questions, can I just make like another array that pretty much switches up the length between the rows and the columns?
Well, that's what we're asking you to. I'm not sure I understand. You do have to make another array. That's true.
I was just wanted to know, like, for example, like you could like make another array with like the row length is equal to the column length of the first array.
Uh-huh. I mean, yes, let's do it. You're right. That's the first step. So the first step would be to create our transposed array, which is going to be a new integer array where the number of rows is equal to the number of columns, right? So data of 0 dot length, and the number of columns is equal to the number of rows, which is data dot length. So yes, this is step 1, but we're not done yet. This is an empty array, so we now have to fill it. I'm sorry?
I just wanted to know if that like first step was right.
Yeah, no, absolutely. But since we're here, why don't we go ahead and finish it up. This is an example of when you would need the nested for loop structure. Absolutely. I need to visit each one of these values and copy it over to my new array. There's two ways you can approach this. Do you want to iterate over this array? Or do you want to iterate over this array? You can do it either way, right? You can do it either way. You just have to keep track of things appropriately. So what is going on with my computer? Please. You gonna work? Okay, we're back. I'll iterate over data. Although if you wanted to iterate over the transpose array and do it that way, you certainly could. Nothing wrong with that approach. Okay, and so then the value at transpose, so ij, or wait, no, let me think about this for a second. The value from data ij is going to go at transpose ji, correct? I'm just swapping the row and the column. And if I spell it properly, that would help. Okay. Trying to visualize it in my head. I think that'll do it. Let's run it and see if there's any errors. That'll certainly... No errors. It didn't print anything because I didn't tell it to print anything. So, the fact that I don't see anything is not necessarily a bad thing. If you really wanted to check, though, you certainly could have it print out the transpose. I think this is it, though. I'm pretty confident that this is, in fact, the solution to this problem. Any questions about this one before we head to another? All right. Anybody else got some more coding or not or questions they'd like to talk about? Yeah.
Semantic one, but like if you were to say make a mistake of putting the transpose that line like under the next bracket, would that be a kind of serious error?
That does matter, yeah. So I was talking earlier about how like missing semicolons and stuff like that doesn't really matter, but these brackets have a huge effect on how the code works. So those, honestly, I mean, really thinking about where these curly braces go is probably one of the more important things on these coding problems, in my opinion. So yeah, definitely take the time to make sure you get those brackets in the right spot. It can make a big difference. Yeah. Yeah, what's next? We have about 25 minutes, 20 minutes. Yes? Number 9? All right, we're asking the user for 2 positive integers. We're then going to generate okay, so one of those is going to be a quantity, and one of those integers is going to be a threshold. So I am going to generate quantity number of integers, right? And then check to see if they are, is it above the threshold or below the threshold? Above the threshold. So I'm gonna, if I ask for 10 random numbers, right, I'm gonna generate 10 random numbers between 1 and 100. And if my threshold is 75, right, I'm gonna count how many of those 10 random numbers were greater than 75 and print out that answer. That's what I want this code to do, right? But I have the ability to specify what I want the quantity and the threshold to be based on what I type in. Okay, so we've given you the head start here. We've given you the scanner code that asks the user to type in the quantity and to type in threshold. And so now we actually need to do the task of generating these random values and comparing them against the threshold. So I need quantity random values. Hopefully from that last problem, or actually the first one that we did, you can see that this is another case where I need a loop that's going to go n times or quantity times. So here's the loop that I would set up to do that. We now have to generate random values between 1 and 100. We should know how to do this. We've talked about random numbers. Math.random. We multiply by the range, which in this case is what? Careful. It's actually going to be 99. The range is the largest value minus the smallest value. I think it actually might be minus 1. I'll have to think about that for a second. But then we do need to add 1 as well, because math.random could give us 0, right? So 0 multiplied by whatever this is going to be 0. So I have to add 1, otherwise it's going to go from 0 to 100, and I don't want 0. Very clearly says 1. So I think this should do it once we add the cast on to an int at the end. For the largest one, 0.99 would be 98.99999 repeating, and that would get us to 99.99. But that wouldn't get us 100, so actually I think it would be 100 here, wouldn't it? Let's see, this could be 99.99999 repeating. Yeah, I think this is right. I think the range is 100 actually, or the multiplication should be 100. Yep. Okay. When we have that value, we now need to compare it against the threshold. What am I going to use to compare it against the threshold? What tool from our toolbox? I'm asking a question, making a decision. Those are all clear indications of an if statement. So if the value I've chosen is greater than the threshold, I need to indicate that I've seen this value. So let me come back up here and make a counter. Start my counter at 0. If I find a value greater than the threshold, I'll increment it. And I don't remember if it says to print it out or not, but I'll do that just because. Let's try it out. If I ask it for, 10 random values and the threshold is 75, 2 of them were greater than, that seems about right. I guess if I do more samples, I get more accurate data. But if I do it 100 times and the threshold is 75, then yeah, I would expect roughly 25 of them to be greater than the threshold. Yes? I use an if statement whenever I'm making a choice or a decision or asking a question. In this particular case, I'm asking the question, is the value bigger than the threshold? If the answer is yes, then I'm going to do this. If the answer is no, then I just skip it. Yeah. If statements are asking a question. They're making a choice, making a decision. All right. I think that'll do it for this problem. Any questions about this one? Yeah.
Could you explain why you put count plus 1?
Why I did this?
Yes.
So I'm trying to count how many random values are greater than the threshold. So if the value is greater than the threshold, I'm going to indicate that I've seen one by, this is like a tally mark, I guess, just like tallying. Starts out at 0. As soon as I see a value that's greater than the threshold, it's now 1. The next time I see one, it's 2. Right? Question? The threshold? Nope. Nope. Yeah. So I'm generating random numbers between 1 and 100 and just counting how many of them. I'm asking you to pick a number between 1 and 100 such that when I generate random values between 1 and 100, I'm asking, are they bigger than the number that you picked or not? That's the threshold. Yeah. Any other questions? Or does anybody have another problem they'd like to see? Yes?
Can you go through question 6 on the writing part?
Question 6. Sure. Is this the password one? Yeah, I did this one last class too. That's okay. Let's do it again. We want to write a program that's going to generate random strings that can be used as password. And so you're given this array to start out with. This is kind of a similar to the, to the array that I was showing you last time. I didn't actually show you the whole alphabet and stuff on the exam. I just said, dot, dot, dot. And said, all right, this is filled with the alphabet, right? But for actually practicing this out, I did have to type out all the letters. So, you can see here's an array of characters. It asks the user to type in how many letters they want their password to have, and now it's our job to randomly choose from that array to construct the password. So it's asking us how many characters here, and hopefully you can see there's a direct relationship between that and how many repetitions we have to do. So just like we saw for the two-dimensional array example, I'm going to set up a loop that is going to iterate from 0 to the length, once per character. I now have to randomly choose a value from this array. And actually, again, this is going to kind of mirror what we saw over here. This is a two-dimensional array, but it's the same concept. I need to randomly choose a value. So, I don't have rows and columns. I just have the one dimension. But this statement will still work. I can still choose random indices using this statement. So if I just kind of borrow this here as the random index that's going to be selected, it's not called data, it's called characters. So that tells me which index I want. And I now have to pull that out of the array and stick it onto my password. What's it called when I have two strings and I stick them together? Concatenation. So we have to do some concatenation here. And in order to pull that off, I'm going to come up here and start my password off as an empty string. This is kind of the equivalent of saying something like int sum equals 0, right? Except for I'm not dealing with an integer here, I'm dealing with strings. I'm saying here is a blank string to start out with, and then I'm going to pick one letter at a time and just add it on. So in order to do that, we'll say something like password. You can actually use plus equals here if you would like to. Characters at I. Or if, plus equals makes you feel uncomfortable and you'd rather do it this way, that's fine too. They are equivalent. Two different ways. It should be index here, not I, because index is what we chose at random. And then once we have chosen all of the letters, we can print out our password. Let's try it out. How many characters? 10. There we go. And if I do it again, I should get 10 different characters the next time, right? I think it works. So here you go. That would be the solution for this one. Well, excuse me. One other thing that I, while my mind's kind of thinking about it, you'll notice like for this problem and for the first one that we did over here, question 4, right? There's not a lot of code here, right? It doesn't take a lot of code to solve these problems. That's intentional. I am not going to ask you a problem that I think is going to require a page and a half worth of code to solve. Now, if you give me a page and a half worth of code and that code works, you will get credit for it, right? But if you're taking the exam and you're writing a really long program for an answer, I would hope you would at least pause and think, well, Professor Shook probably put this on here because he thought of a very simple, direct solution. So maybe there is an easier way to do this that won't require me to write out all this stuff, right? And if you can't think of it and you give me a page and a half worth of stuff, I'll still grade it and give you points if it works, right? But I will not expect that from you. Most of these problems will have solutions that are like, look at this one. It's what, 5 lines, 6 lines? That's kind of the right ballpark that we're talking about here. Yeah.
I did that, but I think I did it wrong. It's with printing one. It's only printing one random character.
One random character? For the one that we just did with the passwords, you mean? I mean, without seeing your code, it's hard for me to say. If it's only printing one random character, then are you doing this inside the loop? Because if you only do this outside the loop, it would only pick one character. But I without seeing your code, I can't really say for sure what the issue is. Question in the back.
Do you need the in.close? Like, what does that do?
This is related to the scanner. This is not something that we've talked about. This is, you can treat this as just code that has been given to you to manage the scanner, not your concern. Any other questions that I can address? We still have 14 minutes, I think. Yes.
I have another question on that one.
Uh-huh.
Why do the characters not, why do they not have to be separated by, like, in a array, why don't they have to be separated by commas?
Well, I took a shortcut. If you scroll all the way down here, you'll see this little split, and that's what does that for me. I could have done it comma separated. It would have been a lot longer and would have made me want to hurt myself, so I didn't do that.
So splits every one up?
Yes, it does, yeah. Yep. Great question. But I wouldn't expect you to know that for the exam. That's just a thing that I'm doing to make things simpler for myself. Any other questions? I have time probably to do another one. Yeah.
I'm just wondering how comfortable should you be with like with string methods?
Yeah, that's a great question. I think somebody asked this last time too. They were mentioned in the text. I know we've mentioned things like substring and some stuff, but we haven't really spent a whole lot of time on them, so I wouldn't worry about them too much. I mean, should you be aware of their general existence? Yeah. Am I going to expect you to be an expert on substring? No, definitely not. There's more important stuff for us to worry about. In fact, I don't think substring appears in any of these practice problems that maybe one, but not very many, and that's pretty an accurate reflection of how important I think it is. Yeah. Great. Okay. I know we still have a little bit of time left, but I'm going to go ahead and wrap it here, but I will stick around for an additional 10 to 12 minutes, so if you do have any other questions, come on up here to the front, and I'd be happy to chat with you after class for a bit. Otherwise, there will be TAs in the lab on Wednesday and Thursday, but like I said, if you've got your assignment turned in, there's no studio, so if you want to use that time to do something else, that's up to you. If you want to come and ask questions about the exam, they'll be there ready to help you out. Otherwise, I'll see you at the exam rooms on Thursday. Let me know what I can do to help you get ready. Thanks.